Hello, my name is David Faure and I work for KDAB. I would like to show you a tool called HipTrack written by a colleague of mine, Million Wolf. HipTrack is all about memory profiling. I want to see where my application is allocating memory and whether I can improve on that. I have this small example here which does a number of string comparisons and then gives me a result. I can run this example in HipTrack by simply doing HipTrack, name of the executable. So it runs the application again, but this time it will record all of the allocations and all of the freeing of the memory. Once it's done, it tells me you simply have to copy-paste this command line here to see the graphical analysis tool for this. So I simply copy-paste, hit enter, and then this window comes up. It loads the trace that was generated by HipTrack, and usually the most interesting place to go is the flame graph. Once I go to the flame graph, I can see memory peak. This is where did the allocations came from at the moment where the application used most memory. If I look at the graph here, I can see that, well, in this simple example, it allocated memory while it was running all the time, so the peak was here at the end. But of course, this could be different in a more complex application. Right, so what we can see here is the memory was allocated by QString list here or by QString number. And if we look at what happens here, we can see that we are appending to a list. And when we append, very often it has to call realloc grow, which means it has to reallocate the underlying data structure. That is something that we can obviously, or we can hope to improve if we have a way to know in advance the number of items in the list, then we don't have to realloc so many times. So let's have a look at the code. All of this here is Qt code. The code that is ours is get haystack. I can do right click, view color codee. It jumps to this other view where I can see the lines of code that show up in this previous flame graph. So there is only one entry here. Obviously, that's where we are doing the append on the list. I can do right click, open in file editor. It will bring it up in Qt Creator, which is here. And it points to me the line where this is happening. And indeed, here we can see I am appending 10,000 strings to a string list, and HipTrack told us that leads to a lot of reallocations. I can fix that by adding a reserve call. I know there are 10,000 entries, so I type 10,000. Obviously, I could use a constant to share the number. Now I can rebuild and rerun. So let's go back here, run HipTrack again. I will get a second recording, obviously. And then what is really interesting with HipTrack is that I can either simply open the new recording and then I will see whether I still see some realloc in the flame graph. Let's have a look here. I see that my reserve call had to allocate memory. That's the whole point of it. But I don't see any realloc anymore. So it doesn't grow multiple times over time. It simply has the right size from the beginning. If I want to see how much I gain by doing that, I can also do HipTrack GUI-D for diff. Give it both files. They are the two ZST files in my current directory. And then now HipTrack is in diff mode. It will show me the difference between the two runs. And I can see that I have a lot less allocation, well, some less allocation functions being called, a lot less memory being used. The number of allocations is lower here. And in here, I can see that instead of 130 kilobytes of realloc, I have a single 72 kilobytes of allocation upfront. So I saved, I divided by 2 the amount of memory that is allocated here. Obviously, in this mode, I can't have a look at flame graphs and things like that. It doesn't make sense. But if I go back to just the latest trace, then we can have a look at other things that HipTrack can tell us. For instance, if I go to temporary allocations, these are allocations followed by immediate deallocation of the same area of memory. This happens very often with temporary objects. And I can see here that all of my temporary allocations, and there are, that would be 100,000, I think. So that's a lot of temporary allocations, and they are all in main when we create a QString from a char literal. Let's jump to that line here. That would be temporary allocations. It's the third entry here. Open the file. And now if I go to my Qt Curator, indeed, it points to a line where we have a temporary QString created from a literal. I could, of course, because it's a literal, I could move it out of the for loop, or I could use QLatin1String, which will not allocate memory. Let's verify if this is true. Rebuild, rerun the application in HipTrack. And then what I can already see here in the summary, temporary allocations 0 instead of temporary allocations a lot, 1 million. So all of this was saved by simply using QLatin1String instead of QString. So I hope you like this tool. HipTrack is very easy to use. It gives you very precise results because it has a complete view of all of the allocations that happened for the memory and all of the deallocations. If you want to use it, it's actually free and open source. You can find it on the KDE GitHub repository and you can compile it from there, or you can download an app image which is ready to use as a precompiled binary. You'll find the link in the description below this video. I hope you enjoy HipTrack. Bye-bye.